Hello and welcome to lesson 1 on one of the best topics ever, integration. Okay, I cannot emphasize enough just how great this subject actually is. Okay, so you've done all the algebra, you've done trigonometry, you've had to sit through statistics, but calculus starts, you do some differentiation, you think, wow, this is really good, and you got into integration. Wow, just blows your mind away. I hope. It's just got everything. It's got the glamour in it with the Newton and Leibniz calculus wars. Okay, it sounds difficult. Okay, if you want to impress someone with your mathematics, you say, "Oh, I can do integral calculus." A lot of the questions are quite simple, but also some of them can be really, really challenging. Some of the difficult ones that look really hard can actually be quite easy and can be done within a couple of minutes. But then some of them just look as though it should be easy, but they're actually really, really hard. Okay, it is the last, or one of the last, chapters in the A-level maths syllabus as well, the pure mathematics syllabus, and there's a lot in this chapter. Okay, that needs to be done. Right, let's get on with it. So, if you look at the very first bit, and I'm just looking at your textbook now. And most textbooks are the same sort of thing. You're confronted with a list of, and here they are, 9 standard integrating functions. Okay, so 1 through to 9, and that needs to be common knowledge. Okay, you need to either memorize those or you need to use them so often that you just remember them by heart. Okay, so a lot of these are fairly simple. Okay, so the first one, for example. It's a standard integrating result, adding the power and decreasing by that power, and add C. The next one, number 2, okay, maybe I'll go for a highlighter pen here, so blue colour. Yeah, number 2, okay, this one here, where you differentiated e to the x, so it makes sense that integrating, being the reverse of differentiation, you integrate e to the x, you also get e to the x, okay, plus C as well. All of these, by the way, have got plus C, so just make sure that every time you are adding C to your answer. Okay. Next one. Well, we've differentiated natural log of x to get 1 over x. So, of course, the reverse operation of that, when you integrate 1 over x, you get natural log of x. Okay. Notice that the answer is written with modulus brackets like this. Natural log. Don't you dare say anything else apart from natural log. Then the modulus brackets x. The reason for that is when we come on to doing substituting limits with integration. Okay, suppose you have to substitute this limit in here. You see -1 to 1. Okay, the modulus brackets there are so that we can actually take the logarithm of a number. Okay, by taking the modulus of it. So that's that. Number 4. Well, when you differentiate sine x, you get cosine x. So the reverse applies when you integrate cos x. You get sine x. Okay. Number 5, when you differentiate cos x, you get negative sine x. So the reverse here is when you integrate sine x, you'll get negative cosine x. Okay. I would say that these ones here, 1 through to 5, they are the kind of obvious ones. You should be able to know those without too much thinking. And then what remains are 6. Whoa, what happened there? Let's try it again. 6 through to 9. Yeah, those are the ones that I would like to memorize. Okay. So what I'm going to do is just remind you of the derivative of tan x. When you differentiate tan x, you get sec squared x. Okay. If you can't remember that, then just write tan x as sine x over cosine x. Okay. And then apply the quotient rule on it, and then you'll get sec squared x. So the reverse, the integral of sec squared x is tan x. Okay. And then these last 3, same again, you've got to kind of know the derivatives of these. So the derivative of cosec x is negative cosec x cot x. If you need to work through that, then you write cosec x as sine x to the power -1, and then just use the chain rule to differentiate that, and you will get negative cosec x cot x. So the reverse of that, the integral of cosec x cot x is negative cosec x. And then number 8, when you differentiate cot x, you get negative cosec squared x. So the reverse of that, when you integrate cosec squared x, you get negative cot x, and the final one, when you differentiate sec x, you get sec x tan x. So the integral sec x tan x is sec x. Okay. Read through these bits, okay, the watch out, the notation, okay, the links, okay. You should have a textbook in front of you, so I'm sure you can do the reading yourself, okay. But I must emphasize these 9 rules here, they are absolutely crucial, okay. And this comes right at the beginning of the chapter. Kind of sets the tone, doesn't it? You might be thinking, wow, those look challenging straight away. No, they are not. They are not challenging. They are the easiest of the easy. Okay, you need to get into that mindset now. Okay, those are very simple results. Okay, right. I'm going to take you through some examples, which may or may not be exactly the same as in the textbook. Okay, so you can either have your textbook open and look at the example at the same time as me going through this, or alternatively what you can do is just have a look at me going through these examples. Okay. Just do note that I don't always do it the same way as a textbook, as is the case with all mathematicians. You know, I've got my own style to it. So the first one I'll look at is this. Okay, first, very simple, very easy integral, which is to integrate 2 cos x plus 3 over x minus root x. Okay. Now, what I would do is I'll just rewrite it slightly. So it's 2 cos x. That's simple. 3 over x, that's simple, and I'll remind you about that in a minute. But when you've got powers involved, or roots or reciprocal functions, just try and simplify it in index form. Okay, so that's x to the power of a half dx. Okay, and then you just integrate each one at a time. Okay, so the first one, 2 cos x. Okay, so if you remember what that rule was, if you need to look it up, okay, there it is again. Okay, there. But I'm hoping that you have got that memorized already. When you integrate cos x, you get sin x. Okay, so the first one is simple. That's just going to be 2 sin x. Okay, and then this next one, the 3 over x. If I just refer you back to those rules again, you got this one here. You see, so integrate 1 over x, you get natural log of x. Okay, so when you integrate 3 over x, you get 3 natural log, and then modulus brackets x. Even when you don't have limits to substitute in, I would say it's a good habit to be into, to write the modulus brackets. And then this last one, x to the power of a half. Well, normal rules of integration, I say normal rules, algebraic rules of integration from what you did last year. Increase the power by 1, so it's 3 over 2, and then multiply by 2/3. That's the reciprocal of 3 over 2, and let's subtract. Do not forget the plus c. Okay, the arbitrary constant. Okay, the Robin to the Batman. Okay, yes, even though these lessons are a little bit online, I'll try and inject some of my humour in there as well. Okay, right, so that's that one. What I suggest you do is, if you didn't understand anything, you pause the video, you rewind it. Okay, you can't do that when I'm actually doing it in class. You would ask me to go through that again, and I will go through that again in class, but since it's a video, you've got the opportunity to pause, rewind, and I'll go through it again. The only thing is, it'll be precisely the same next time I go through it. So if you've got any questions about anything, you just drop me a line. Okay. Alright, next example. Integral cos x over sine squared x minus 2 e to the x. You might be thinking, what's going on? You said these would be easy. You know, cos x over sine squared x. So there's no way. Yeah, I'm sorry, but yeah, you need to be able to simplify any trigonometric expression. Let's just take a look at. Whoa! Oh, nice. There it is. That's not the page I wanted. Let's just take a look at these rules here and see if there's anything in there that can help us with that. Okay. So you had a mixture of things there, didn't you? One of those integral results might just help us, but it's not going to help us until we can rewrite it. Okay. So let's see. You've got cos x over sin x, so that's cot x, isn't it? Okay. And you've also got an extra 1 over sin x, so that's cosec x. If you do have your textbook open, hopefully you found the rule already. Okay, we've not actually integrated anything yet, so I'm going to put the integral sign in, and the next one is just ridiculously easy, isn't it? Subtract 2 e to the x, okay, dx. Okay, so you got cot x x cosec x. Let's just have a quick look. Cot x x cosec x. Sorry. There we go. It's that one there. Okay, and it's rather simple, isn't it? You just get negative cosec x. Woohoo! That was really good. As long as you can memorise these in the exam, that is an easy question. Okay, so negative cosec x. Let's just put that in. Okay, so negative cosec x. And you're going to find when you're doing the first exercise, you may be referring to that term list. Okay, what I'd ask you to do is see if you can do it by memory first of all, and then look at the list just to check to make sure you are correct. And of course, use the answer in the back of the book to check you're correct as well. And then the last one, 2e to the x. Okay, and then just don't forget the plus c. And that's it. Okay, so can you see with this question, apart from just this line I'm highlighting here, there's just an answer really. Okay, and some of you are in a position where you can just write down an answer. These are called simple questions or inspection questions, and inspection is something I'm going to be talking about in the coming lessons as well. There are some integrals you need to be able to just look at and just write down the answer with no working. There's one more which I'll take you through. Okay, so this is a bit of a wordy one. Okay, or it's as wordy as it gets with simple integration. So given that a is a positive constant and the integral with limits from x equals a to 3a of 2x plus 1 over x dx is equal to the natural log of 12, find the exact value of a. Okay, right, well, let's just rewrite the integral first of all. Okay, so limits of a and 3a. Now with a fraction like this, when you've got just one term on the denominator, you can just divide each term on the numerator by that. Okay, so what we're going to do is we're going to do 2x divided by x, which is just 2. And we'll do 1 divided by x, which is 1 over x. Okay. Now you need to be perfectly happy that these two are exactly the same. Okay. And I hope you'll agree that integrating 2 and integrating 1 over x is actually quite simple. Okay. So we've got dx there. Do I want to write the natural log 12 bit? No, I don't need to. Okay. Examination tip: if you don't need to use the natural log 12 bit yet, just save a bit of time. Just put it in once you've done the actual integration. So let's integrate this. So integral of 2 is 2x. Okay, integral of 1 over x is natural log of x. I would be using the class to ask these questions, but I'm in an empty room at the moment. Okay, I'm just hoping that you can do these, and to avoid long pauses, here's a tip for you. You could just pause the video, okay, on your own time, and then just think about it. Okay, and hopefully it will take you a short amount of time to get the answer. Okay, but I don't want to leave long silent pauses in the video, you see, so you've got to try and take that initiative. Have your fingers hovering over the mouse button. Okay, and now when we've got limits substituted in, remember use these straight line brackets. Okay, and the limits go on the right hand side there, so a and 3a, and you substitute those in. Okay, so it's substituting 3a, so you get 2 times 3a, so that's 6a, plus natural log of, now when you've actually substituted the value in, okay, you don't need the modulus brackets anymore. Okay, and we know that's definitely a positive value, see, because it says that a is a positive constant, so we don't actually need to put the modulus brackets in. Okay, and then you've got to subtract. My advice is when you're subtracting more than one term, you put in brackets so you don't make a mistake. So you substitute a, and you get 2a plus natural log a, and you're subtracting all of that, you see. Let's just simplify that. So 6a subtract 2a is 4a, and then you've got natural log 3a subtract natural log a. Okay, should we just do a bit of work on the side here? So natural log 3a subtract natural log a. You remember your logarithm rules, so what you're going to do, yeah, you got it, you'll divide that, aren't you? So that's the same as natural log of 3. Oh, doesn't that work out nicely? Okay, so that's the rule, natural log or log, but all things are natural in this part of the course anyway. So I just thought of a Star Wars quote there, which I'll share with you later. Okay, that's an insight into my mind. When I'm doing these things in lessons, all these things pop into my head. Star Wars is always in my head, you see. Okay, especially when I have to say things like natural. Okay, so I'll give you the quote now, because I think it's the dark side of the Force is a pathway to many abilities some consider to be unnatural. just a little insight into me there. As soon as I said all things are natural, I just thought of Palpatine just saying that wonderful scene. I might just watch that when I get home. Okay, I'm in the mood for it now. Anyway, let's have a look. So what was I doing? There's a natural log of x, y is natural log of x plus natural log of y, and natural log of x over y is equal to natural log x subtract natural log y. So remind of your logarithm rules there. Okay, so we need to use this here. So the natural log x minus natural log y, natural log 3a minus natural log a, so x over y, so 3 over a, which is natural log 3. So let's just put that in then. So the natural log 3 subtract natural log a, that is natural log of 3. Okay, right, so that's that. I clear my board at a fairly fast rate. If you need it, pause the video. That's great. Right, now I'm going to use the bit where it says equals natural log 12. So I'm going to write 4a plus natural log 3 equals natural log 12. There we go. So 4a is equal to natural log 12 subtract natural log 3. We use the same logarithm rule again. So 12 divided by 3 is 4, so natural log of 4. And then we get a equals 1/4 natural log 4. Ta-da! We've done it. Okay, so that was the last example that I thought I'd go over with you. Hopefully you've understood all of those. Okay. What you need to do now is just work your way through the first exercise, which might be called exercise 11a or might be called something different if you're working from a different textbook. I would say all of the questions are standard questions. So when you get to the examination style questions, they're not worth many marks at all. You need to be able to do them very easily. If you get to any questions that you do find difficult, just make sure you understand why it should actually be simple. Okay, there is some expanding of brackets to be done. There's some fractions to be done. Maybe some rewriting of powers. There is maybe using the odd trigonometric expression and simplifying it. Okay, but you should be able to work through the first exercise fairly quickly. Okay.